Namaste, this is Maulya, studying in Sri Venkateshwara College of Engineering, 6th SEM from the Department of Artificial Intelligence. Today I am going to present about the topic application of biogas and the application of biogas in engines, which comes under the subject renewable energy. Today we're going to discuss about the topic biogas, application of biogas and the application of biogas in engines. What do you mean by renewable energy? Renewable energy is something which comes out of the source which never runs out. See, these biogas, it is a renewable energy source. It is produced by the breakdown of organic matter anaerobically, which means this process happens in the absence of oxygen. Here you can see in the slide that this gas primarily it consists of a methane, carbon dioxide along with small amount of other gases like hydrogen sulfide and ammonia. So here is an introduction to biogas covering its production, benefits and applications which we go through in the next slide. Now let us see how the production of biogas takes place. At the first step, we will see about the anaerobic digestion, which usually takes place in the absence of oxygen. So this anaerobic digestion is a process which involves microorganisms breaking down the organic materials such as the agricultural waste, manure, municipal waste, plant material, sewage, green waste or food waste. These organic material will be broken down by the microorganisms in the absence of oxygen. So these involve the feedstock, which commonly includes the animal manure and food scraps, agriculture residues and the wastewater sludge. Next, the stages. In this anaerobic digestion process, it consists of 4 stages, that is hydrolysis and acidogenesis and acetogenesis and methogenesis. So this hydrolysis usually the process contains the breaking down of complex organic molecules into the simpler molecules. In this stage, these the complex organic molecules it will be break down into the simpler molecules by the microorganisms. Next, moving on to the acidogenesis. These smaller molecules are converted into volatile fatty acids. Next, moving on to the acetogenesis. The further breakdown of acid takes place, which converts itself into the acetic acid, hydrogen and carbon dioxide. Next, moving on to the methanogenesis. This production of methane and carbon dioxide from the acetic acid, hydrogen and carbon dioxide takes place. Next, moving on to the next step, biogas digester. These are the systems designed to facilitate the anaerobic digestion process. So this step designed to it facilitates the anaerobic digestion process which takes place in the absence of oxygen. They come in a various designs including the batch digester and the continuous digester. This batch digester it is loaded with the biomass and left to digest to say over a period of time in a set period of time. Next, this continuous digester it constantly fed with the new biomass and continuously produce the biogas. This is the difference between the batch digester and the continuous digester. In the previous slides, we learned about the concept of biogas and how the production of biogas happens. Now, in this slide, we will discuss about the benefits of biogas, and these includes the renewable energy source, waste management, reduced greenhouse gas emission, nutrient-rich byproduct, and the energy security. So coming to the renewable energy source, as a renewable source, biogas helps to reduce the dependence of fossil fuels. So we usually depend upon the fossil fuels, and with the help of this renewable energy source, this biogas helps to reduce the dependence on these fossil fuels. Moving on to the waste management, effective in managing and reducing the organic waste, thus minimizing the pollution and the environmental impact. So next, moving on to the reduced greenhouse gas emissions, which was usually affecting our environment and the human health. Capturing methane from the waste prevents its release into the atmosphere, where it could act as a potent a greenhouse gas. Next, moving on to the nutrient rich byproduct, the digestate, that is the material remaining after the digestion process. That digestate can be used as a nutrient rich fertilizer, enhancing the soil health and reducing the need of the chemical fertilizers. With the help of this nutrient rich byproduct, we can reduce the use of a chemical fertilizer. Next, moving on to the energy security. So this local production of biogas at can energy security reliance on the imported fuel. So now moving on to the application of biogas. First we'll discuss about the electricity generation through biogas generator and the microgrids. In the biogas generator, this biogas acts as a internal fuel combustion which will produce the electricity to the homes, business, etc. And this microgrids, it acts as an alternative to the traditional infrastructure, which when lacks, this microgrids come into existence and it provides a reliable electricity. Next, moving on to the heat production through direct heating and district heating system. In this direct heating, this biogas can be burned in the boilers for the residential, commercial and industrial application. These include space heating, water heating and produce heat in the industries. Next, moving on to the district heating system. In some areas, this biogas is used in district heating system where it generates heat centrally, then it is distributed to the multiple buildings where the heat is produced in a single area and it is distributed to all the surrounding buildings. Next, moving on to the combined heat and power, that is CHP system, which includes the efficiency maximization and industrial applications. This efficiency maximization includes the CHP system. It is also known as the cogeneration system. It uses the biogas to produce both electricity and heat simultaneously, which we saw in the other two applications, that is electricity generation and the heat production. These both can be included in the combined heat and power system. This efficiency maximization, it includes the production of both electricity and heat in a simultaneous way. These systems have the higher efficiency rate compared to the separate heat and power generation because it saves energy, saves human power, and as they utilize the waste heat and the electricity productions. Now we will discuss about the specific applications of biogas in engines. This includes the same applications which we discussed in the previous slides. Now we will discuss how it impacts in the engines. So electrical generation, on-site power production, farms, wastewater treatment plants, and industrial facilities often use these biogas engines to generate the electricity on site. This can meet the internal energy demand and reduces the reliance on the external power sources. Next, moving on to the combined heat and power system, this efficiency improvement that it doesn't let the waste go off. It utilizes the waste productions, and the biogas engines in the CHP system can achieve high efficiency by utilizing the both electrical and thermal energy produced. So next, moving on to the industrial applications, which includes the process energy and the operational reliances. In the process energy, industries requiring constant heat and power such as food processing, chemical manufacturing and brewing can use this biogas engine to meet their energy needs. So in the technical consideration, we come across the biogas quality and the upgrading, that is impurity removal. Biogas need to be cleaned to remove impurities like hydrogen sulfide and moisturized to prevent the corrosion and the damages in the engine. So usually engine and the metal appliances, it exposed to the corrosion. So this biogas needs to be cleaned to remove impurities to prevent this corrosion, and upgrading to the biomethane for application requiring the high quality fuels. Biogas can be upgraded to the biomethane by removing the carbon dioxide and the other contaminants, making it equivalent to the natural gas. Next comes the engine modification, that is the fuel system adaptation and the maintenance. Engine may need to modify itself according to the requirement, and maintenance, that is the regular maintenance, is crucial to ensure engine longevity, that it doesn't harm the engines, harm the internal part of the engines, and efficiency, particularly in removing the deposit formed from the impurities in the biogas. Next, moving on to the environment and economical benefits, that is renewable energy resources, greenhouse gas reduction, and the cost efficiency. So now let's summarize what we have learned. In this presentation, we learned about the renewable resources and how the biogas is produced and its benefits, and how the biogas impact itself in the engines, and how with the help of this biogas we produce energy, we produce the heat, and we produce the electricity, and how this biogas helps in different industries like agriculture, and in the electricity production, and in the heat production, and how it reduces the waste productions, and in the overall the application of biogas in engine, it offers a sustainable and efficient way to generate the power and heat without the maximum amount of wastage. And even if the resources get wasted, it is utilized to produce the more resources, and this is how the biogas works. And it is sustainable and the versatile solution to energy needs and waste management challenges, and it usually converts the organic waste into valuable energy and byproducts, and the biogas production supports the environment sustainability, and as I told, it reduces the greenhouse gas emissions and contribute to a circular economy. Investing in biogas technology is not at all only to address the energy and waste management issues, but also to foster the economic development, especially in the rural and the agriculture communities. Thank you for watching. Please do like the video. Thank you.